Good evening. I'm Steve Prevette. I'm your speaker tonight on the subject of one of my favorite people, Dr. W. Edwards Deming, and some of the stories of interactions using his methodology. My background is I actually went to Virginia Tech as a civil engineer, thought I was going to build bridges and roads, ended up on nuclear submarines. I did get to interview with with Admiral Rickover. Picked up a master's degree in operations research, all things statistical. And in my last command, I was a total quality management quality leadership coordinator, I have to say, of a Navy submarine data facility. Was a task I had to do, and I had to read Dr. Deming's Out of the Crisis, which is kind of a fun read to always say it for the first time. After leaving the Navy, I got picked up by the Hanford nuclear weapons site, a later transfer to Savannah River. I'm now in South Carolina. I did retire from the nuclear jobs 3 years ago, and I currently teach online for Southern Illinois University at Carbondale to their information technology people, and I have their statistics course, so I end up covering a lot of the materials we'll cover here. So let's get on into this. There we go. I do want to give credit to Phil Monroe and Bill Cooper, and also Doris Cronkite. They're from San Diego, and Phil and Bill work very closely with Dr. Deming. Their stories are documented, and they are my mentors. So I do give an acknowledgement that this presentation is actually a follow-on to that. But first, if anybody's willing to chime in, after a negative event or accident, how many of you observed the person in charge asking who did it and who's going to be fired? Anybody willing to unmute and at least acknowledge that statement?
Yeah, I mean, they always ask you, "Oh, what happened, who did it," rather than the firing part.
Right. Now, I actually did overhear several times the senior management morning meeting from my cubicle. Sounds scary. And yes, we had a chief operations officer who was always, who's at fault and who's going to be fired, where obviously his intent was the person closest to the problem. So we'll talk a little bit about that as we go on here with the topic. Now, one of the interesting things is I got involved somewhat with the 737 MAX 8 back during the crashes. And in fact, I have a topic for my students. And a funny thing, I was working at the Savannah River National Laboratory, and every month, bless their hearts, raised in the South here, they do a safety meeting. Now, the manager opened the safety meeting was asking, suppose that these air crashes, which were I think everybody's remembers those. Plus, you got the current astronaut stuck on the space station. You had the door blow out on another Max. Let's say, but it was a software issue that was closest to the problem. So the manager opened with, what can we do to prevent computer programmers from making errors? So this is kind of an interesting question, because if you're familiar with the 737 MAX, yes, there was a software program that told the elevator to basically crash the plane. But the existence of that program was hidden from the FAA. It was hidden from the pilots. There was some rather odd reasons they made it. So I actually raised my hand and said, hey, the software did exactly what it was supposed to do. It was designed to do. It just was in the wrong system. And of course, the manager's response was, well, this is what we're going to discuss for our safety meeting, how to prevent a programming error. So let's get on with that discussion. Kind of a lost opportunity, shall we say. I'm a systems guy. In fact, for the model railroading hobby, we actually model the operations of a railroad. When I'm done here, I should pan the camera around the room a little bit so that you can actually see it. But systems is what we're going to get into here. Now, from Dr. Deming, some good quotes that I always like, though I have modified them to be gender neutral, shall we say. That if only a person had known the purpose of the program, what was the purpose of the program they were doing on the MAX 8, they could have done it right for the purpose, even though the specifications were deficient. And in fact, that's what was going on. The way the plane was responding and the software was acting, it was improper specifications. Now, we see this a lot too. As long as management is quick to take credit for a firm's successes, we always find that failure is an orphan. And yes, we tend to blame the workers for the failures. So these, I'm sure we've seen. Unfortunately, I think Boeing is going ahead, continuing with the same problem and not solving it. I will just say there's an interesting show called Almost Live that if you Google Almost Live Boeing press conference, it's a really old skit that was done on this Almost Live show. It really predicts what it's 25 years old, but you'd be amazed if you watch that video. Almost Live Boeing press conference. All right. So a bad system will beat a good person every time. Now, perhaps I'm starting off a bit negative, but basically, if Japan, we have the television show, If Japan Can, Why Can't We? The Out of the Crisis book I said I had to read as the Total Quality Leadership Coordinator, and the New Economics. So let's get into this. At least I've made the problem statement that we don't tend to think about our systems, and we tend to blame the person closest to the problem. So, Dr. Deming, you may know he had the 14 points, which included things like don't set numerical targets, eliminate performance appraisals, kind of some interesting stuff that most people go, I can't do that. But he later developed the system of profound knowledge, SOPK. And what this is the four pieces of it, but I do divide it into the hard side and the soft side. Tom Peters said that hard is soft and soft is hard, if you ever want to read some interesting stories there. So, what we have is on the logical side, the left brain side, the hard side, shall we say, is appreciation for a system. How do things fit together? And believe me, I was on nuclear submarines. You better understand the submarine as a system, shall we say. If we were always quizzed on if I open this valve, if I do this, what will happen to the submarine. Then there's the theory of variation. Now, this is where we get into statistical knowledge. The answer is never 3. The answer is 3 plus or minus some value. There is some sort of error band there. I do notice that the national news of late has been very good on these polls about saying, is the difference between the Republicans and the Democrats within the margin of error or not? So at least there is some of that getting out there. I don't know if people quite understand where those numbers come from, but at least know they exist. However, Dr. Deming, who was a PhD physicist, so you would think very left brain, he ended up incorporating psychology. How do I know what I know? There's a rather interesting 1929 book he quotes, and the theory of knowledge. I'm sorry, psychology, how do people fit together? Theory of knowledge, how do I know what I know? A couple of principles here, and I do throughout this presentation. There's a copy of going to be made available, so you can get these links. Dissection of a system destroys the system. For example, if you want to prove if your hand writes or you write, cut your hand off and see if your hand will write. Actually, Dr. Russ Akoff uses that as an illustration of destroying a system. We need to understand our trends. When are our results stable? And I guess anybody following the stock market, this has been a rather interesting week, shall we say, for stability. Though in the long run, it looks like it's staying stable, but we certainly have had a short run this week, shall we say, in the stock market. Now, this is where the who did it question comes in. How do people interact with processes, materials, and each other? A similar model is for those aware of the fishbone diagram. And also, and we're going to talk stories about these things, so I'm going to illustrate them. How do I know what I know? And that's a concept called operational definitions, and I definitely do have a story on that. Now, this is also from Dr. Russ Akoff. Appreciation for systems. This is a simplification of one of his stories, but and I'll open this up to somebody to answer it. I guess I won't open it up. I could put it on the slide. Would putting a Rolls-Royce Merlin engine, now that's the engine that was developed in World War II to power a Spitfire fighter, into a smart car make an improved automobile. Certainly a smart car is smart. It's obvious. And that's a really good engine for powering a Spitfire. Now, is it going to power a smart car? Well, the engine's probably twice as long as a smart car, so I don't think it's going to work too well. And so Dr. Akoff had stories related to that. So I just can't mash two things together and say, these are both best in class. Why don't they work together? Uh, with the variation, we've got our probabilistic versus deterministic. Now, of course, I have a very deterministic goal here, which is to finish this presentation by 6:45. So I have a little clock I'm watching. So linear cause and effect here. If you do this, that will happen. Now, probabilistic, however, is where we get into in the real world, is the exact time, location, and effect is random. For example, number of injuries per month. For those who are familiar with calibration, I once said a laboratory was, I had to kill some time. They said, well, look at whatever you want in a laboratory. So I pulled a few calibration books, and in every calibration, the as found reading exactly matched the specification over and over and over and over and over again. I'm like, this can't be right. There's got to be some variation that happens, some small amount of drift that they catch when they do a calibration. Well, upon asking, come to find out the person doing the calibration was told, oh, in the as found, you just write what the specification was once you've set it to specifications. So that caused quite a consternation in how their calibration program is being run, shall we say. Yes, you always want to record what the as found reading on the equipment when you're trying to calibrate it so that you know how much the equipment is drifting, which is certainly some ASQ body of knowledge on that. Now, what happens too is I've seen managers present apparently random numbers, like a budget. If you've ever gone to a senior management meeting where somebody's going over the budget, they say, oh, the budget was this amount and we spent this amount. And the reason we spent $1 more was blah, blah, blah. Or we had 5 injuries last month. We've had 4 injuries this month. Oh, that's a fine improving trend. As we know from the stock market, invoking that again, past results may not guarantee future results. So let's talk about the losses. If I explain all my random stable processes and react to every individual result, okay, injuries are up by 1 this month, injuries are down by 2 this month, I will be making a mountain out of a molehill. And usually this turns into continuing to do the same thing over and over again, but expecting results to be different. So if I have a stable process, it's going to keep varying. And usually I do something called a control chart, which I'll demonstrate to say, is it stable within that band? Now, however, if I do miss the detection of a significant change in the data, for example, I was with a contractor that took over operations from a previous contractor, and they were all happy that injury rates were going down. Injury rates are a big thing, yes, for safety, and quality hopefully works with safety too. But they were doing a 12-month moving average, and I got a pretty fast drop. The injury rate dropped by about 40% within the space of 2 months. But the problem is, by doing the 12-month moving average, it stretched out that decreasing trend. So a year later, they haven't realized that injuries are not getting better. They got better 10 months ago and then stabilized. So they lost the opportunity to keep improving. So this is a basic statistical process control chart. We were talking about Dr. Deming's red bead experiment. If you want a physical demonstration, I've even got on the internet at the Hanford site. I did a Dr. Deming's red bead experiment. You can always YouTube and watch Dr. Deming do it. But this is kind of the typical result of a red bead experiment, which is pulling basically, pulling red beads out of a supply of red and white beads, which is usually driven by about the proportion between the two beads. And of course, the results will be different. And if you react to every single difference, you'll drive the workers crazy and you won't get any better. Now, psychology tends to be a little more interesting, and for those of us who are engineers, sometimes confounds us. But how will the people be influenced by management policies? For example, if you stick a poster on the wall that says, "Be safe," is that demonstrating that management knows what's going on, or is it demonstrating they have not a clue what's going on? It's interesting to go do a tour of a plant and look at the posters on the wall admonishing for certain targets, or making, hold the handrail, or making various and strange things that won't change the system. We often forget that nobody gets up in the morning and looks themselves in the mirror and says, "I'm going to do a bad job at work today." And there is a resistance to change. We probably saw that in politics recently with the decision by President Biden about was he going to run again or not. Certainly, there was a lot of resistance to change there. And if you haven't heard of it, it's confirmation bias, that a lot of times we will observe something and we categorize it according to how we think the world occurs. This is why you can have two people watch the same event for like a court case and have two completely different descriptions of what happened. Or if you've never seen the gorilla video, which is you're asked to count the basketball being passed between a bunch of white shirted people and black shirted people. And while you're trying to count the basketball on the video, a guy in a cheesy gorilla suit comes out, goes in the middle of the circle, pounds his chest, and leaves, his or her chest, and leaves. And maybe 10% of the people saw the gorilla appear in the video. If you haven't heard of him, he's a submarine guy, but David Marquette has a lot of things about psychological ownership. For example, I used this a lot with managers I had, because it would be, "Boss, I intend to do the following." Rather than going, "Boss, I request permission to do this." This is like the junior officer going to the captain and say, "I intend to submerge the ship." And all men are below, hatches are shut, ship's rigged for dive. What's the depth of water beneath the keel? Are we in the right water where we're authorized to submerge? These are, I will attest to, these are all things you have to check before you submerge. But notice the wording is different than what I did to the captain. It's, "Captain, I request permission to submerge the ship." Here, this captain has turned things around and put the onus on the more junior manager, saying, "Okay, what are you thinking, and what have you done to prepare to submerge the ship, or do any sort of project at work that you intend to make a modification, you intend to start a project," rather than saying, "I request permission to." Now, of course, that takes a little bit of discussion between managers and the junior officers, shall we say. But the really interesting video is Greatness by David Marquette. It's about 5 minutes. It's extremely humorous. I definitely recommend it. Now, what theory of knowledge? This is the really soft one. How do I know what I know? Now, the best example I found was, how does a child know not to touch a hot stove burner? Did they find it out by touching the hot burner? Yep, that's hot. I don't want to do that again. Or did they follow the direction of their parents or grandparents or whatever custodians they had that said, "Don't touch a hot burner"? Based upon either one of those two inputs or both, the child formulates a theory. A stove burner may be hot, and hot things hurt. So basically, probably as a child, you never touched the stove burner, whether it was on or off. And this is from a book. I actually found it in Portland, Oregon at Powell's Books. Anybody on the West Coast probably has heard of Powell's Books. I did find a copy of it. It's called Mind and the World Order, C.I. Lewis, 1929. I basically did not read the book cover to cover, basically read sections of it and was kind of overwhelmed, I have to admit. But this is a nice, simple thing about, how do I know what I know? And this is important when you're measuring something. How do I know? For example, Orville Redenbacher, and I did this actually in classes, used to say that his popcorn popped less unpopped kernels. than the other brand. Well, what's an unpopped kernel? How do I, is that where just a little bit of the popcorn is popped? Is it a solid kernel? Two people could count a pile of supposedly unpopped kernels and get two different answers. So I need a theory when I'm doing my measurements. So as we're talking about measurement and decision making, no amount of examples proves a theory. Chanticleer the rooster thought because he crowed in the morning, the sun came up. Well, one morning he overslept and the sun came up anyway. He had to revise his theory. That's a story Dr. Deming usually used. Of course, all I need is one negative example to disprove the theory. I know there's a book called The Black Swan. Nobody thought there were black swans until somebody found one in Australia. However, there's no knowledge without theory. Uh, how do I know the right way to drive to work unless I have a theory as to which one takes the least time? And does that vary with time of day? Is it different on my morning commute versus my afternoon commute? I have to admit, my commute is walking up the stairs, so there's not too much to worry about with my commute. But we modify our theories so I could fall down the stairs. Yeah, I do watch for that. I hold the handrail. We modify our theories based upon observation and experience. And without theory, there's nothing to revise and nothing to learn. That's a good phrase for college students that I deal with. So, oddly enough, Dr. Deming came up, there's no true value of any measurement. Now, this is not that there's no true value of anything. Some people misquote him. It's a true value of a measurement. Um, I forget which consultant told this story, but he would have even children and sometimes adults say, how many animals are in a box of animal crackers? Well, number one, the answer is zero. There are no animals in it. But if I ask how many animal crackers are in it, and let's say, they're, if you ever had them as kids, there's the cow, there's a head of a cow, and there's a body of a cow. Is that one animal cracker or is that two animal crackers? Give a person a very micrometer to measure something, and micrometers can, read the 4 or 5 digits. Depending on how the person uses it, which is part of gauge R and R, you may get two different answers from two different people of the same object being measured. So there's a link to my red bead experiment. Um, I do say that if you're having trouble anytime with trying to convince somebody they need to understand variation, they need to understand systems, the Dr. Deming's red bead experiment, which takes about a half an hour to an hour to watch, is a very good convincer of understanding how numbers can vary when you're doing the same thing over and over and over again. Obviously, there I have my clenched fist and my willing worker, and the guy in the wheelchair looks like he's kind of leaning back, like, "Oh my word!" That is kind of how you be the manager of a red bead experiment. But we go through firing the worst workers, all sorts of. There's a worker of the day, and all these things do nothing to change the number of red beads in the paddle. You're supposed to be getting white beads. Red beads are defective. And so management, and you'll see I did not listen to the workers. We just kept doing the same thing over and over again and failed. Okay, you've listened to me kind of drone on a bit here for the first 25 minutes. Now, I have found it's always better to tell stories. And so here are some personal stories. I hope that as we finish up and people are asking questions, that maybe you'll share a story or two of your own. But let's go on into that. And in fact, I'll take a little moment here. Does anybody have any questions they'd like to ask at the moment before I get into stories? I'll wait an appropriate period of time here. Okay, on to the stories. I mentioned that I was in the Navy, and my last job in the Navy was at a torpedo maintenance facility. And yes, the Navy at that time, this was the early 80s. I'm sorry, the late 80s, about 1988. The Navy had actually implemented total quality leadership. They had watched if Japan can, why can't we? And it invoked Dr. Deming's methodologies. Now, oddly enough, one thing driving us, we were not meeting the submarine Atlantic fleet, which is what sublant means, quota of processing 10 torpedoes a week. Basically, uh, they take out torpedoes and shoot them as exercise torpedoes without a warhead. They float after they're used. They come back. We have to clean them up and put them back out to use as exercise torpedoes. That kind of is done because in World War II, they went into submarine warfare in World War II with torpedoes that had never been tested. And come to find out, in real world conditions, the torpedoes did not do very well. They didn't go boom when they hit the ship. Uh, so there's an interesting quality story to that, and they did not want to spend the money to test torpedoes. So they do actually fire them without a warhead and recover them. Also, the torpedoes that are in the magazines for actual use in a war have to be pulled every so often and inspected. So we're supposed to do 10 of those a week, and we were maybe, if we're lucky, we're doing 4 or 5 a week. Chief petty officers, those are the senior enlisted guys in the Navy, like command sergeant majors. I worked with them and said, I need to get some data. I had my operations research degree. I'd read out of the crisis. So I figured, well, let's figure out what's going on. So give me records of how long these tasks take. So I got, you know, at least one observation, usually about 3 or 4 if it was more common, about how each task, they were all broken in different worksheets, took. And I kind of figured out maybe I better look at where the backlogs are. And I measured the inventories before starting critical steps, made a tour of the shop, counted up how many parts are in the pile waiting to be processed, or how many torpedoes were waiting to be testing. And we actually, because these were fairly advanced torpedoes, they have a lot of computer circuitry in them. They have an automated test line, which is the final stage to accept the torpedo. And we put a lot of effort into them. There were 4 automated test lines. The senior petty officers were the electronics experts. They ran the automated test equipment lines. So I looked at the usage logs for these lines, figuring that these were the critical component. That's what everybody assumed. That was what everybody perceived, was that the automated test equipment, boy, we got to keep that thing up and running. Well, when you look at the logs, there was only 3 in use at any given time. There was always an ATE inactive, not because it was broke, just because there wasn't a torpedo to put on it. However, when I went to look at one of the early stages, which was cleaning the torpedo engine, these things actually run off of something called auto fuel. It's got a self-oxidizer. It burns underwater, leaves a lot of soot, a lot of crap. In fact, the exhaust gas is hydrogen cyanide. That doesn't matter in the underwater, but obviously doing maintenance, it does. So these things are done in a clean room, which, because of the possible hazardous chemicals, the workers are in white suits. They have to memorize the procedures because you can't have the procedure in the room while you're cleaning these grungy engines. It is just a really bad job, shall we say. I'm going to not use some colorful language like a Navy sailor would, but this is not a fun job. And so this seemed to be the big problem, because there were all sorts of torpedoes that once they got their engines, they went zip right through the line, but until they got their engine. Now, actually, I didn't know this at the time. I read the book later about theory of constraints. This was the constraining system, was cleaning the engines. Many senior personnel were assigned to keep the test equipment running. On the other hand, we had only 2 very junior third-class sailors who were qualified and assigned to do engine cleaning. So if one of them went to training or took leave, we were definitely in the hurts for getting engines cleaned. And yes, it was a nasty job. So I did go to the captain, as kind of having done the analysis as a lieutenant. He was a commander, I was a lieutenant, and said, well, sir, if we want to get our production up, we got to forget this idea we're a 4 ATE shop, we're a 3 ATE shop. And if one of the test equipments is down, don't sweat it. If we lose a second one, we got a problem. However, we got to get some more sailors doing engine cleaning. So some of these electronics people became engine cleaners, shall we say. And within a few months, we were kicking out 10 torpedoes a week. And the odd thing, which is a strange thing about quotas, we ran out of torpedoes to process. There simply weren't any torpedoes due to be worked on once we got all the backlog out. And usually during an annual inspection, which lasts a week, you hardly produce any torpedoes. We actually cranked that out during a full-blown audit inspection. We made 10 torpedoes that week. So by understanding the system and understanding some of the psychology about why people weren't doing, wanting to do the engine cleaning. So let's talk about system profound knowledge in this story. So again, I looked at the whole system and how do we get things through it. Did not get too much into variation. I didn't have a lot of data to deal with, but at least when we tested the result of what happens when we put on more engine cleaners, it worked. Now the psychology piece was there because the psychology was the electronics senior petty officers were proud of their ATE. They came in at all hours of the evening if one of the ATEs went down. It was really hard to convince them, no, if one is down, we're not going to worry about it. And how did we know what we know? So this is all about interactions between the sailors and the materials, our interactions with the submarine force in terms of were we providing torpedoes when they were needed? Were we keeping the torpedoes maintained? And how did we know that? So that's how we can use the SOPK model to say, okay, what are these four things that are going on? Now, primarily it was the system and psychology that played in this story. Now, after I left the Navy, I went to the Hanford site. I was actually originally hired to be a maintenance supervisor of high-level tank waste. That was by Westinghouse Hanford. Within 6 months, I had been shoved out of being a maintenance supervisor in training, and to meet the need for the government wanting data, I went to some training that Phil Monroe and Bill Cooper did in Excel 4.0. Shows you how long ago that was. And they wanted control charts of cycle times of doing corrective maintenance. Boy, does this sound familiar to the torpedo facility? How long does it take to do a job? Okay. So I'm like, okay, I get this idea. And of course, I'd been trained on control charts. So the training went really good. I was off of on the job training for 2 days. But about 5 days later, I got woken up one morning, and actually I'd done some SPC also, and got my boss got my wife woke me up at noon. I was on swing shift, and I'm like, why is my boss calling me? And he says, get in here now and start making control charts. And come to find out, this is one of those career-defining events. The Department of Energy government kept asking Westinghouse for control charts of maintenance cycle time. And Westinghouse said they didn't know anyone who knew how to get data and how to make control charts. And Phil Monroe and Bill Cooper were in the meeting and stood up and said, oh, yes, you do. And his name is. So I'm told my name went to the head of the site, SES, whatever level, and they authorized pull him off of being maintenance supervisor training and get him in and doing data. Now, for 28 years, that was the entirety of my job description and my job title. Get in here now and start making control charts. During 28 years, I was a civil engineer, a consultant, a safety engineer, a safety scientist, an environmental engineer, and my last job title was senior quality engineer. And I did the same thing under all those job titles, and I had about, I'd say, 24 managers in 28 years. Plus, near the end, I was working for 4 different facilities. I was going up the Chalk River in Canada several times a year. Now, this is an interesting, I've removed the facility name. It was a facility at Hanford. About how did this is kind of an interesting way to display data. I was able to track all these means. We basically got a request origination. This piece of equipment is broke. It went to planners. It went to be approved by safety and every engineers and everything. It got on the schedule and then it was worked. And then we closed it out and cleaned up the job and it went to retain complete. Well, that's the theory. come to find out 31% of the packages that went in to be approved got kicked back to planning. So there's a kind of a good constraint right there to work on. There's all sorts of other backflows. 10% of all work requests got canceled, which seems like, well, why did I go to all that work? And come to find out, almost a quarter of completed work packages got canceled. Now, that was an odd one to figure out what was going on there. So this was a rather interesting graphic. I called it a bubble chart. I mean, it's basically a flow chart, but with real data. How long did each of the paths take? You'll see some of them, like planning to completion, they decided that, okay, we really didn't have to do anything, took no days. But you see, like from approval back to planning took 12 days. So that's a pretty expensive loop backwards. There's a 43-day go all the way back to planning. So you see, it's just out of control. It's, well, I hate to use the word out of control. It was very stable. So we did find there was a lot of inadequate and duplicate work in the corrective maintenance backlog. Planners were invoking requirements without training the workers. This led to a lot of failures in the field, and we implemented actually a process delay notice. So if you had a field failure, actually, one of the times as a maintenance supervisor, I went to the electronics shop I was to eventually be the supervisor of, and probably 80% of the workers were in the shop. And it's like, well, why are you not in the field? Went to the field, there was no RadCon person, so we canceled the job. I went to the field, there was no tag out. They canceled the job. I came back to the shop. You know, this was, I even saw that when I was a manager in training about what that was going on. And usually it was because jobs died for lack of stuff. And so we did categorize, did Pareto charts of what the failures were. And come to find out, radiological controls people, we had it's about like engine cleaners. We had very few of them, and they scheduled the jobs as if they had, let's say, 12 of these people, but we really only had 8, and usually 1 or 2 were on training or on vacation at any given point in time. So the schedule was a complete waste of effort, and in fact sent workers the wrong place, because you'd have 5 workers show up and there's no RadCon person. So we did get improvement in cycle time. So what was really odd, though, was I don't know if anybody's around for re-engineering, but basically a competing methodology came in, and they were tasked to further reduce the corrective maintenance backlog and increase output. As it turned out, I showed the flow chart and what we were doing to this re-engineering team, and this is interesting. They declared it too complicated to show management. So management never got to see, except for the few managers I showed it, they never got the big picture of, well, what was going on with the process. But the re-engineering team, bless their hearts, they doubled the rate of corrective maintenance completions. But what they did was they changed the operational definition of what counted as corrective maintenance. So things that were modifications or preventive maintenance or all sorts of other kinds of maintenance got counted as corrective maintenance. In fact, about a year after they did this, yes, a manager called me and I said, well, look, all they did was double the definition of corrective maintenance. So now we got twice as big a corrective maintenance backlog. So Dr. Deming would always ask by what means. What these people did was basically change the operational definition to make success. Another thing they did was they developed a short form, which was to compress literally a 2-inch thick package for doing nuclear work down to maybe 1 page. Like if all I do was change a light bulb in a non-nuclear program. Oddly enough, they did no metrics on it. I asked, okay, are you going to keep track of the metrics? Well, after it was in place for a year, I was directed by the vice president of this facility to determine the decrease in cycle times. And unfortunately, the maintenance cycle time had doubled because they never tracked how long these short forms took. So all we had was the data on much longer work packages. Of course, that vice president did not go to the president and say, well, the corrective maintenance cycle time doubled after we did this. Of course, yes, probably what we would have needed to do was find all those old 1-page packages and waste a lot of time trying to determine how long did they take. But because they never planned ahead for how to measure, there we were. So appreciation with the system again, what is corrective maintenance versus preventive maintenance? How is the data changing? How do the planners interact with schedulers? What's the issue with radiological controls people? And how do I know what is corrective maintenance? These all throw into. So we actually did have the theory of variation because I did control charts on the cycle times. They were relatively stable. How do I know what I know? How do I know what's planning, what's scheduling, what's corrective maintenance? What was the psychology going on about changing the definition of corrective maintenance? And of course, all this existed in a system, which is rather well captured by that bubble diagram. This actually, I do want to prove that people have used this at Pantex out in Texas, and I believe some of this has made it to Oak Ridge also. Uh, a lot of talk about human reliability and high reliability. Well, the person out there, Richard Hartley, is also was a fan. I don't know if he's still involved. It's been a number of years, but he developed this system to map the system profound knowledge to high reliability organizations, uh, which I suppose probably Eastman does. Human performance and high reliability. So this is a mapping of uh, learning and adapting as an organization, fostering a strong culture of reliability. How do these things map to the system profound knowledge? So I can use the SOPK along with Plan, Do, Study, Act we talked a little about before to improve my systems, basically. So here is a path forward. And I do like this statement by Dr. Deming because, at some time I felt like I was beating my head against the wall. How can these people be so stupid? No, you can't think that. And sometimes I think I was kind of kicked off to retirement because, like at Boeing, I was finding too many problems, and management decided that it was time to not be finding these problems, that we were good enough. So a few things happen in that in life to folks, but I was very happy. Actually, I will just say I was happy to actually retire at 62. I found out I could financially do it. I go off on cruises. I'm teaching college courses. In fact, I can teach my college courses from cruise ships. We just came back from a 31-day cruise. It was New York City to Barcelona, Spain, by way of Greenland and Iceland. So we went all over the Atlantic, shall we say. So life is good. I do appreciate a lot of the theories I learned from Phil Monroe and Bill Cooper and Dr. Deming. So this is a good phrase. You probably have read it by now as I'm talking. But once the individual understands the system profound knowledge, they will apply its principles in every kind of relationship with other people. They will have a basis for judgment of their own decisions and for transformation of the organization they belong to. In fact, we were having a little discussion before this talk about, well, how do I deal with artificial intelligence? Well, perhaps we should take SOP and see, well, how do I judge how AI is operated, and how do I determine if it's highly reliable or not? Not an easy job, but at least this gives us a roadmap. And again, I've modified many of these Dr. Deming quotes to be gender neutral. So he said, an individual once transformed will set an example. Hopefully, I've done that over the years. Be a good listener, but will not compromise. Okay, continually teach other people. I'm happy to be able to do that with this presentation and through teaching at Southern Illinois, and help people pull away from their current practice and beliefs and move into the new philosophy without a feeling of guilt about the past. So we can walk away from judgments, walk away from who's going to be fired, and look at, well, how did the system fail? And there's lots of system stories out there. The Boeing story still has got to be written here. And I would say, definitely, since this has been going on for 25 years, Boeing has got a crappy system. Here are some links for more information, some YouTubes that I've done, a couple of webinars that are out there. I guess this one will make it to the YouTube, and so when you get this, you can go click that, or you can Google those and find them. So I think I met my goal here, about 45 minutes. So what I would like to ask some folks is what will you do different tomorrow as a result of perhaps what you learned today? Any questions or